Hello everyone, in this video I'm going to show you show you or review how to evaluate functions at an x value. For example, in this case, we're going to let every x in our function equal to -2. We're going to do two parts here. When x equals -2, we substitute -2 every time we see an x. And if you do this carefully, -2 to the third power, exponents before multiplication. -2 to the third power is -8. -8 times -2. -2 times -2, 4. 6 times 4. And -2 times 5, it's positive 10 and 9. These two together makes a total of 19. 24 here. And then positive 16. Using the calculator, we can get 16 plus 24 plus 19 makes a total of 59. So we say that f of -2 is 59. Evaluating when x equals 3 is the same thing, but this time we're going to change every x. See, every x is going to be substituted by a 3. And do it carefully. 3 to the 7th power makes 27. Then we multiply that times -2. 3 to the 2nd power is 9. 6 times 9. And -5 times 3 is -15. Notice how this right here gives us a total of -54. And this is a positive 54. So they add up to 0. -15 plus 9 makes a total of -6. So we say that f of 3 is -6. When x equals 3, y is -6. Keep this numbers in mind, because I'm going to show you now how to check this on decimals. If you go to decimals and you type in your function, notice I already have it pre-typed here. This is a graph, and please notice how the point -259 is right on the graph, because when x equals -2, you go up 59 units. Notice the second number we got was 3, -6. When x equals positive 3, y is -6. And so this is one of the ways you could check your answers. If you need to evaluate a function, you could check it graphically. Now this is what we call long substitution, or direct substitution, I should say. We just directly substitute the numbers into the function, evaluate them. But there is another way we call synthetic substitution. Synthetic substitution. And to do this, there's a much easier way by just considering what we did for synthetic division. We do the same thing here. We're going to take the coefficients -2, 6, -5, and 9. And we're going to substitute when x equals -2. So because we already know what x is equal to, we don't change the sign. We just bring it down as a -2. And then we proceed to do the same thing we did for division. So this is -2. -2 times -2 is positive 4. 4 and 6 makes 10. 10 times -2 makes -20. -20 and -5 makes -25. -25 times -2 makes a total of 50. And 50 plus 9 makes 59. So what did you notice here? Synthetic substitution, this, what we used to call the remainder, it's now our answer when we substitute it. So this is f of -2 is 59. The remainder is the answer to the substitution. We could check that briefly on the next one, on the next example. Notice how we had a -2, 6, -5, and 9. And now we can just substitute 3. Follow the same steps again. Bring that -2 down. -6 plus 6 is 0. 0 times anything is 0. -5 times 3 is -15. And -15 and 9 make a total of -6. And that's what the answer was. So this is another way to do synthetic substitution. Another way to evaluate at an x value. If we have a polynomial function, it has to be a polynomial function. Please Let me see if I could do another example with that. Let's go ahead and call it example 2, I guess. Evaluate f of x at x equals, say, -1 using synthetic substitution. Okay, so with f of x equal to, let's say, -3x to the 4th plus 6x to the 3rd minus 11x plus 5. Since we're going to use synthetic substitution, we need to go ahead and leave zeros for the missing exponents. So we write -3 for the x to the 4th, 6 for the x cubed, 0 for the x to the 2nd power because we don't have any, -11 for the x, and 5 for the number with no x's for our constant term. Since we're going to substitute, or we're going to try to figure out what f of x gives us when x equals -1, put a -1 here. -3 times -1 makes a total of 3. Remember, we add this way, so that's 9. -9 plus 0 makes -9. Negative times a negative is positive. This is -2, and this is 2. So f of x gives us a 7 whenever x is -1. Negative ones and ones are not too hard to evaluate, but this is just another way of doing it. We call it synthetic substitution. Please rewind this video, take notes on it, and use it to evaluate functions of this type.